Welcome. We're going to talk about parent functions and transformations. Hopefully you recognize all three of these. The first one being the quadratic. This is the parent function that is y equals x squared and goes through 0, 0. So it's supposed to be on the vertex there. This one is the absolute value parent function because all these negative values, negative 1, negative 2, negative 3 have all turned positive. So that's y equals absolute value x. And then finally this last one here is the positive square root function. So this is y equals the square root of x. These are all the parent functions because they're not decorated with anything added on or multiplied on or anything like that. Very quickly, we're going to talk about function notation, and we're going to make use of it, in fact. Function notation is just a different way to name these, because right now I've got these all named y. And if I wanted to, I was like, well, let me just arbitrarily, I'm going to name this one g of x, which is the way you say that. And that just means when I refer to g, the function g, I'm talking about x squared. And whatever I plug in here, that's actually what's getting plugged in for x. I'm going to call this one h of x. So once again, I'm just going to refer to my absolute value function by the letter h. And then finally, the last one I'm going to call k of x. And that's going to be my square root of x. So later I'll be talking about each one of these, so you'll need to remember g is x squared, h is absolute value of x, and k of x is square root. All right, moving on. So we can transform these by either adding inside the function or outside the function. So what that looks like is for the absolute value, for the my g of x, my x squared, I could write, if I wanted to, so I'm going to say y equals. So once again, these all get mapped back to the y. Even though I'm calling them different things, I plug in the x and I get out a y. So instead of x squared, if I say g of x plus 2, what I'm really saying is, well, that's y equals x plus 2 squared. Okay? That's what I'm plugging into the function. I'm replacing x with x plus 2. Similarly, I could say, well, okay, instead of saying x squared, I want x squared plus 2. That makes a little more sense. I'm plugging outside the function. So that's just saying x squared plus 2. Now, this does something very interesting, and we're not going to spend a lot of time talking about why it does this. You can verify it on your calculator. You can do it with tables. But basically what happens here is, for this function, this moves this over to here, to negative 2 for the vertex, and this one actually moves it up to here. And if I wanted to verify that on my calculator, I'm going to pull this off for a second so you can see it on the calculator. I've got all these plugged into the calculator already. Pull it up here. I think you can see that without too much glare. If I graph these, so it's y1, y2, y3, or these would be maybe g, f, well, different letters. This is another reason we do it. These are all variations of g of x. But if I graph it, so they're going to graph it in this order so you can see what happens here. So when I hit graph, it's going to graph the first one, that's our parent. There's our second one with plus 2, and there's our plus 2 on the outside. Okay, so just the way you do it on the calculator. You can verify that. You could also go back and look at the tables. If I hit second and graph, it'll give me the tables. And I can see, oh yeah, okay, there's 0, 0 for my parent function, but at 0, 4, which is actually my y-intercept for that y2, my 0, therefore negative 2, 0 is now my new vertex for that second function. And the third function actually doesn't even go all the way down to 0. The lowest it gets is 0, 2. All right, so that happens. And the same thing will happen with the absolute value function. With the absolute value function, if I do y equals the absolute value of x minus 2, that shifts it actually the other way. So that would shift over this way. And if I did y equals the absolute value of x minus 2 on the outside, that would actually take that parent function that we had and it would shift it down. Okay? So, and what we often say is the outside of the function is intuitive because it moves where you think it's going to move, And inside the function, it's counterintuitive. It actually, -2 actually results in a +2 shift. All right, quick quiz. So let's do it with, let's say y equals k x minus 1 plus 2. Reminding that's the absolute value function. What's that going to look like? Doing both still works this way, so that's going to look like, pause it if you need to. So my absolute value, the shape stays the same, but this is counterintuitive on the inside, so -1 actually means it's going to move it over to +1 here, and +2 on the outside is going to move it up to here, so this is going to start there, and then my shape is going to be that square root shape. And essentially the endpoint, it's not really the vertex, but the endpoint of that has shifted over 1 to the right and up 2. Okay, moving on. So we can add and subtract. We can also multiply. Now we're not going to worry about multiplying by 2 or by 1/2, although those are interesting things you can look at as well. We're going to talk about just multiplying by -1 because largely we'll let you investigate it later, and I'm trying to keep this video to 10 minutes. So what happens here? If I plug in a -x on the inside of the function versus the outside of the function. So let's try this with both. So if my g of x, if I take my original equation and say, okay, well that's -x² on the inside versus, oh wait, do I not want to do that one? Hold on. No, I do. And y equals -x² on the outside. Actually be x², I guess I don't need parens. This one right here is a little tougher to tell because it actually looks like the original if I do it that way. So this will actually look like the parent function. It's not actually, but it looks very close. The second one though, most of you probably know this if you've looked at this, anytime I get a negative out in front of the x², it flips that guy over. Alright, but I'm going to say this one out here still essentially looks like the parent function. This is not the best one to look at for this particular example. So let's look at k of x. Let's look at the square root function. So if I do y equals the square root of -x on the inside versus y equals -square root of x on the outside, well this does exactly what I'd expect it to do. It flips it upside down. So it's helpful if you know this rule, this will help you remember this because this is going to do something different. So that actually just flips that guy upside down like that. Looks essentially like that. Now if I can get it in the screen. This one over here becomes more apparent what it does. When I do this here, what it actually does is it flips it this way. And so this right here flips it upside down. If you can remember that one, you can remember this one, and remember, oh, this flips it the other way. It flips it across the y-axis. And then finally, I wasn't going to say this, but I'll throw it in here. If I was to do a a negative of a -x, that will actually make it reflect twice. It'll end up down in the from the first quadrant down into the third quadrant. So if you do both inside and outside, it's a double reflection. Okay, quick quiz. And we're going to move on. Okay, what if I did y equals -h of x plus 4 minus 3? We're combining everything here. Okay, so think about that. First of all, you have to remember that h is absolute value. And so that's, got to think about what that looks like. So this is really y equals negative. I'm going to write it this way because this is what it is in our calculator. Instead of the bars, x plus 4 minus 3. This minus out front is not going to affect where our vertex is. Our vertex is still going to follow that rule. So we know our vertex is going to be at -4 and -3. And then we know this is going to make it flipped over. So this is going to look like this. I'm hoping this is right because I'm doing it live. It's going to be at -4 following that pattern and down -3 following that pattern. And the parent function is a v, but this is a v that slipped over. So I think it's going to look like that, and we're going to quickly verify this on our calculator, and then we'll be all done. Okay, let's go back to y equals. Let's clear all this out. It's a little hard to find. This is under math. We're going to go to number, absolute value. I hit enter, ABS, except I want a negative out front, negative, and we're going to do x plus 4 and minus 3, and I sure hope I got this right. Hey, what do you know? There it is. Ciao.